Hello and welcome to my short video on probability and conditional probability. In this video, I'll introduce its history, basic concepts, and Monty Hall problem. What is probability? Probability is a mathematical way to measure how likely an event is to occur. It's expressed as a number between 0 and 1. A probability of 0 means the event is impossible, while a probability of 1 means it's certain to happen. For example, flipping a coin gives you a 50% chance or a probability of 0.5 of landing heads or tails. Looking at the history of probability, one of the earliest pioneers was Girolamo Cardano, an Italian mathematician who analyzed games of chance, particularly dice games. His work marked the beginning of quantitative probability calculations. In the 17th century, the field gained momentum through the correspondence between Blaise Pascal and Pierre de Fermat. The 18th century further saw developments with Jacob Bernoulli, who introduced the law of large numbers, followed by Andrei Kormagalov in the 20th century. Basic concepts of probability. An experiment is an action or procedure that produces a specific results. Think of flipping a coin, rolling a dice, or picking out a card from the deck of playing cards. Why? Because while tossing a coin, the result could be either heads or tails. Rolling a die is another experiment with possible outcomes ranging from 1 to 6, and the same could be said for the deck of cards. The sample space is a complete set of all possible outcomes of an experiment. For example, flipping a coin, the sample space is heads, tails. These are the only two possible results. An event is any subset of the sample space. For example, in rolling a die, an event could be rolling an even number, which is a set of 2, 4, and 6. A probability of an event is the measure of how likely it is to occur. It is calculated by using the formula probability of A equals number of outcomes in A divided by the total number of outcomes in the sample space S. So this is a chart describing the probability rule, which states that for independent events, their probabilities are combined directly, since one event does not influence the other. For dependent events, the probability of the second event is adjusted based on the outcome of the first event. Complementary events are pairs of events where one happens if and only if the other doesn't. For example, rolling a 6 on a die and not rolling a 6 are complementary events. The formula for complementary events is the probability of A not occurring equals to 1 minus probability of A occurring. Mutually exclusive events are events that cannot occur at the same time. If one event happens, the other is impossible. For example, when rolling a single die, getting a 2 and getting a 3 are mutually exclusive, because the die cannot show both numbers at once. Independent events are those where the occurrence of one event does not influence the likelihood of the other event occurring. In other words, the outcome of one event has no effect on the outcome of the other. The dependent events are those where the occurrence of one event affects the likelihood of the other event occurring. The outcome of the first event changes the probability of the second. Conditional probability is the likelihood of an event occurring given that another event has already occurred. It is denoted as the probability of A given B. The examples are picking a deck of cards when the previously pulled card has not been placed in the deck before pulling out the new one. Now let's look at the Monty Hall problem. It's a problem setup, and let's understand that. You're presented with 3 closed doors, door A, door B, and door C. Behind one door is a car. Behind the other 2 are goats. You choose one of the doors, say door A. At this point, you have no information about what's behind the door, so the probability of your choice being correct is 1 by 3. The host, Monty Hall, knows what's behind each door. He opens one of the remaining 2 doors, saying door B, to reveal a goat, and never revealing the car. Now Monty gives you a choice, to stick with your original door or switch to the unopened door. Before any doors are open, the probability of the car being behind the door you initially chose is 1 by 3 or 0.33%, but once open it becomes 2 by 3 or 0.66%. This is because there is an equal chance the car could be behind any of the 3 doors. Now, the Monty Hall problem is unique because the host always opens one of the remaining doors to reveal the goat. The action provides additional information about the location of the car. Monty's actions reshape the probabilities because his choice is not random, it depends on where the car is. Therefore, saying the conditional probability helps us analyze the situations by making changes in our choices based on probability. Let's look at some of the real world examples that we have using probability. Examples include weather forecasting, insurance, medical diagnoses, traffic, and transportation. Here are some of the references for my presentation. That will be the end of my presentation. Thanks for listening, and I hope you found it interesting.